Welcome to another physics class. Today we want to look at the topic force displacement graph under work. And don't forget, this is our third lesson under work. So if you are just joining us to understand today's lesson, please try as much as possible to work towards our two lessons on work. So as I said, force displacement graph. From what we have done in our previous lesson, already we know that work done is equal to force multiplied by displacement. So when you now say force displacement graph, it means force will be on the vertical axis in Newton, then displacement will be on the horizontal axis in meter. So when you have such graph like this, it now depends on the shape of the graph that will determine the work done. If the shape is in form of rectangle, something like this, then the area under the force displacement graph, that is this area now. So the shaded area now, the shaded area is equal to work done. And since this shaded area in mathematics is a rectangle, so the work done on this one will be equal to force multiplied by displacement. That is, apply mathematics formula, that is, in terms of length multiplied by breadth, that is force multiplied by displacement. That is when the shape is in form of rectangle. But let's say the shape is in form of triangle like this. This is triangle now. Also, as I said from the beginning, force will be on the vertical axis, then displacement will be on the horizontal axis. Now, the area under this force displacement graph now is a triangle. So you can now say work done will be equal to area of triangle. And area of triangle in mathematics will be equal to half base times height. So depending on the shape of the force displacement graph, then the area under the curve on line of that force displacement graph will give us the work done. Now let's take this one as example 1. From the figure below, calculate the work done. Now, if you look at this shape now, definitely this shape is a rectangle. And area of rectangle in mathematics, you can now say work done is equal to area of rectangle. Area of rectangle. And from there, the area of rectangle in mathematics is length times breadth. But if you look at our vertical axis now, first, this line is 5 Newton. The horizontal axis, which is displacement, this point is 6 meter. So the work done now will be equal to FD, which is equal to 5 multiplied by 6. Then it will give us 30 Joules. That's the simple, from this question, that's the simple calculation we need under it. Let's take this one as example 2. Calculate the work done from the force displacement graph below. Look at this one now. The force displacement graph, the area under this force displacement graph, that one is a triangle. And once it is a triangle, the solution to this one, the work done, will be equal to area of triangle. And area of triangle in mathematics will be equal to half base multiplied by height, depend on the shape. Now, from this one now, our B, that's half multiplied by F multiplied by D. So there we are going to have half multiplied by, here is 10. When you trace it to this side, that's 10 according to the question. Then the displacement, 4 multiplied by 4. So 2 here, 2 here, that will be 10 multiplied by 2. So this one will give us the work done equal to 20 joule. That is for example 2. Let's take this one as example 3. From the figure below, calculate the work done. Pi is equal to 22/7. Now, since pi is given, if you look at this figure very well, it means this figure is half of a circle. And once this one is half of a circle, solution to this one will now give us work done is equal to, that is pi r square, that's the area of a circle. So this one is a half of a circle over 2. And our r there is, so it will now give us pi d square over 2. And if you look at this one now, since our half, this one is a semicircle, so the half of this circle will give us, from here to here is 6, then from here to here will be 4. So this one will now give us, that's 22/7, then multiplied by, that is r square over, 4 square over 2. So this one will now give us 22/7 multiplied by 16 square, 16/2. So we cancel this one, that is 8. So we are going to have work done is equal to 22/7 multiplied by 8. 22 multiplied by 8. Now this one, 22 multiplied by 8 will give us 170, then divided by 7. So the answer will be 25.142 joule. That's the solution to example 3. Let's take this one as example 4. A force varying linearly with the displacement act on the body as shown above, that is from this figure. Calculate the work done, calculate the work done on the body during the first 10 meters of the motion. That is from this diagram now. We have to calculate the work done on the body during the first 10 meters, and this is the 10 meters. You draw it like this. That is from here to here. That's the first 10 meters. And if you look at it now, solution, if you redraw this diagram to fashion the question, so it will give us something like this. Let's say this is the first 10 meters, and this place is 0, and this place is 20. Mind you, to this place, this is 10. So according to the question, that's 10. So if you look at it now, consider the work done along this shape now. We can now say that this shape in mathematics is a trapezium. We can now say that the work done now, work done during the first 10 meters equal to area of trapezium. And the area of trapezium in mathematics, work done will be equal to half into A plus B bracket H. Now it is now left for us to identify our A and B and H in this diagram now. Mind you, when you have a traversation, there will be two parallel lines. And from the shape now, this is one parallel line, this is the second parallel line. So the first parallel line, the length A, according to the question, that is from here to here, is A, which is 10. Then the second parallel line from here to here, B, is 20. And the distance between the two parallel lines, we form the H, which is the height of the trapezium. So the distance between this place from here to here, that is 10. So H is equal to 10. So put this one together, we are going to have work done in the first 10 meters is equal to half into 10 plus 20 into bracket 10. So this one will now give us half into 30 into 10. So 2 here, that is 5. That is 30 multiplied by 5. So this work done now, work done in the first 10 minutes, 3 times 5 will give us 15. That is 150 joule. That's the answer is 150 joule for the first 10 meters. Let's take this one as example 5. From the figure below, calculate the work done. Then this one, pi, is equal to 22/7. Now, the solution to this one, if you look at this figure now, from here to here is force, and from here to here is displacement. And if you look at it, from here to here is 15, while from here to here also is 15. That's so that compare this one, relate this one to mathematics figure. This one will be a quadrant. So with the work done will be equal to area of a quadrant. And that one, since this one is a quadrant, that one will be pi r squared over 4. And mind you, our D is the same thing as r here. So this one will now give us the work done, will now give us 22/7 multiplied by the r there, from here to here 15, from here to here, that will be 15 squared over 4. So this one, the work done now, will now give us, that will be 22/7 multiplied by 225/4. So multiply 22 multiplied by 225, 7 multiplied by 4. So work done, 22 multiplied by 225, that would be 4950 divided by 28. And the answer to this one will give us work done equal to 176.79 divided by, that's the final answer, joule. This one as example 6. From the figure A and B below, find the difference in their work done. This is figure A and this is figure B. The first thing we are going to do is calculate the work done in figure A, calculate the work done in figure B, and the question asks us to find the difference. Now subtract B from A. So let us calculate work done in A. If you look at this A now, from here to here, this is 10 as force. From here to here, this is 20 as displacement. It means work done equal to area of rectangle. And that one will now give us length times breadth according to the shape, that will be FD. So this one will now give us work done equal to 10 multiplied by 20. So this one will now give us 200 joule. Now for B according to the shape, it's a triangle. Work done in this area. So it will now be equal to work, that for B now, work done equal to area of triangle. And that one will give us work done will be equal to half base times height. And from this one will now give us half multiplied by 10 multiplied by 15. So from this one, here, that is 5. So that's 5 multiplied by 15. So work done will be equal to 75 joules. Now, to find the difference now, difference between work done in A and B, that will be work done equal to the difference now in work done is equal to work done in A minus work done in B. And work done in A is 200 joules. That is minus 75 joules. Then the answer will give us, that will be 125 joules. That's the difference between the work done in A and B. Let's take this one as example 7. From the figure X and Y below, calculate the difference in their work done. Calculate the difference in their work done. If you look at this figure and you look at the second figure, this is Y. So we have to calculate the work done, the difference in work done between X and Y. Now, if you look at X is a 3/4 of a circle. So you can now say work done in X for X now. Work done will be equal to, so if this one is a 3/4 of a circle, that will be 3/4 pi r squared. That will be the formula, since we said the area bounded by the force displacement is the work done. So that's 3/4 pi r squared. And don't forget, our pi remains the same, that's 22/7. So the work done in this one will now be equal to 3/4 multiplied by 22/7. We have there 12. That's 12 squared. So this one will now give us 3/4 multiplied by 22/7 multiplied by 144. Now, 4 can go in 144. 4 here 1, 4 here 3, 6. So that will be 3 multiplied by 22 multiplied by 36 divided by 7 now. Now, the numerator will give us 2376, then divided by 7. So work done will now be equal to 339.43 joules. That is for figure X. Now, the next thing to calculate for figure Y now. For figure Y, without wasting our time, this is a triangle. So the area bounded by this force displacement, then work done will be equal to area of triangle, and will be half base multiplied by height. So according to this diagram, that's half multiplied by 10 multiplied by 20. That's 2 here, 2, that's 5. 5 multiplied by 20, that is the work done, will be equal to 100 joules. So the difference now, difference between X and Y. That will be work done between x and y equal to work done in x minus work done in y. So that will be 339.43 minus 100. The final answer is equal to 239.43 joule. That is the work done between the figure x and y. Now let's stop on this example 7, and we thought the series of examples that we done today on force displacement graph. I believe you should be able to understand the subtopic. And if you have any problem on it, please, you can ask your question from the WhatsApp link under the channel. And mind you, as I said in the beginning, for you to understand this topic better, please try to watch our first and second video on word so that you have better understanding when you come to this last lesson. And don't forget to like, share, and subscribe. So when I upload a new video like this, you will be able to get the notification in time. Thank you.